Welcome to Science Access. In today's class, we're talking about stoichiometry in chemistry. If you know you are new to this channel, please kindly subscribe and put on the notification so that you get notified whenever I post a new video. What is stoichiometry in chemistry? Stoichiometry can be defined as a quantitative relationship. Remember the word quantitative relationship, quantitative relationship between reactant and product in chemical reaction or in chemical equation. All right. I will use a very simple reaction to explain the concept of stoichiometry. Let's assume that hydrogen reacts with, remember hydrogen is a gas, reacts with oxygen molecule to give water, right? Remember, water is actually a liquid. This is also a gas. Now, we may be asked, what quantity of this may be required to get this quantity of this? What number of mole of this may be required to get this certain quantity of this? That is all about stoichiometry. It's a reaction, or is a kind of concept in chemistry where you derive a quantitative relationship. In some cases, it can be mass-mass relationship. In some cases, it can be mass-volume relationship. Or you can even be talking about moles. Now, let's use this one to illustrate the first example. The first thing that you have to do actually is to balance the chemical reaction or the chemical equation. How many mole of water do we have here? Just one. We have two oxygen here, so we have one oxygen here. I will be teaching how to balance chemical reaction in a separate video. Let me just balance this myself. All right. So you put two here and you put two here, and this is actually balanced. You realize that you have 4 atoms of hydrogen here. 2 times 2 is 4. 4 atoms of hydrogen. How many atoms of hydrogen do you have here? It's also 4. 2 oxygen atom here. All right. How many atoms of oxygen do you have here? It's actually 2 because this 2 is multiplying everything. So this is 2. So this chemical reaction is balanced. Now, if I ask you, how many mole of water will you derive by reacting, imputing 20 moles of hydrogen molecule? Now, it's a very simple concept. 2 mole of hydrogen here gives how many mole of water? 2. So 20 mole of hydrogen we actually give how many water? 20 mole of water. And also, we can also decide to check the relationship between oxygen and the water molecule. All right. You realize that 1 mole of oxygen actually gives rise to what? 2 mole of water. So if I now ask you to calculate also the amount of water produced from 20 mole of oxygen. So if 1 mole actually gives rise to 2 mole, 20 of this will give rise to how many? It's actually what? 40. It's a very simple concept. Or you can just cross multiply this times this. You can make this one x. How to do it is just make this one x. So you now this times this and this times x. So x is now equal to 2 times what? 20. X is now equal to 2 times what? 20. So x is what? 40. So 20 mole of this will actually give rise to what? 40. Now let's now deal with mass-mass relationship. Let's talk about mass-mass relationship. All right. Assuming, for example, that in this equation above, 20 or 200 grams of oxygen is imputed into this chemical reaction. How many, or what's the amount of in gram of water that is what produced? Remember, this here, the molar mass of oxygen is actually 16, but we have to multiply by 2. Remember, what is the molar mass of oxygen? It's 16. But oxygen molecule has 2 atoms of oxygen, so you have to multiply the 16 by 2. So we now have, here is what? 2 times 16, which will give us what? 32. So here, we now have 32 oxygen, actually 32 grams of oxygen give rise to Remember, we are talking about mass what? Relationship problem. Give rise to this. You can calculate the molar mass of this. Hydrogen is actually 1. How many atoms of hydrogen do we have? 4. So now have times 4 plus oxygen here is actually what? 16, but times 2, which is 32. 4 plus what? 32, which is what? 36. So the molar mass or the molar mass of this is actually what? 36. So which is 36 gram in terms of what? Mass. All right. So 22 gram of oxygen actually produces what? 36 what? Gram of water. And we are now asked that how many will 200 gram produce? X. It's very simple. It's very simple. How do you calculate that? Just cross multiply. So this times this and this times this. So you now have this times this and this times. So you now have 32 times x is equals to 200 times 36. All right. Now I have 32x is equals to 7 2. If you use 2 to multiply this, you actually have 72. Then add the 20 to it. How do you get your answer? Just divide both sides by what? 32. So now I have 32x all over 32 is equal to 7200 all over what? 32. So you can use your calculator to eventually get the answer, and your answer will be what? In gram. So using the hand method, you actually got 225 what gram. You can use your calculator to actually cross-check the answer and tell me if I'm right or wrong in the comment section. All right, so it's a very simple concept. In chemistry, there's another way you can solve this anyway, but I'll explain that when I'm talking about the question and answer segment. This is just an introductory class to how to calculate, or introduction to what? Calculation in stoichiometry in chemistry. All right, let's take a look at another question. Let's assume that we are asked to calculate the mass of calcium oxide produced by heating 500 gram of limestone. Right, 500 gram of limestone. Limestone is actually calcium carbonate. So you'll be given the molar mass of some, for example, calcium is 40, carbon is actually 12, oxygen is what? 16. All right, so you'll be giving this as constant. They are constants in the periodic table. All right. Now you're going to be asked, the first thing you're supposed to do is just write down what? The chemical what? Equation. All right, so we have that. We know that CaCO3. If you hit it, you have calcium oxide plus CO2. All right, so this is a balanced chemical equation. We have one calcium here. How many carbon do we have? One here. How many oxygen do we have? 3 in the reactant side. We have 1, 2, 3. So the chemical reaction or the chemical equation is actually balanced. In the standard exam, you have to put your solid, your gas, and all that in bracket. All right, so please take note of that. But let's concentrate on how to answer or to calculate this simple question. All right, the first thing that you should know is this: calculate the molar mass of this, so that you get the mass of this that actually we have to produce this. If I calculate the molar mass of this, for example, carbon is actually 12 here, right? Oxygen is 16, but 16 times 2. 12 plus 16 times 2 is actually 32. 32. So we now have our answer, final answer as 44. So here we have 40. The molar mass is gram per mole, but we are concerned about the mass here. So the mass is 44 gram. What mass of this actually produces this 44 grams? So let's calculate this. Let's get the molar mass. They will now express it in gram to get the mass that produces what? This. So calcium is actually 40. So we have our 40 plus, this is 12 plus 16, which is O times 3. It's actually 48. This plus this is 60. So this is 100. So you notice that 100 gram of this actually produce. So we are not concerned with the mass of, the question is talking about calcium oxide. So let's calculate for this. Here is 40 and here is actually what? 16. So which is 56 gram. But we also compare with this one anyway. So 100 gram of this produces 56 gram of this. According to the question, if you now hit 500 of this, what is the quantity, what is the mass of calcium oxide that is actually being what? Produced? So 500 gram to produce X. So 100 gives this, 500 gives X. Just cross multiply. So we now have this times this and this times this. So we can just give our simple stuff as 100 times X is equals to 500 times what? 56. All right? So we can now put it this way. 100x is equals to all right? So you can use your answer, your calculator to actually verify what I did. I just use 5 to multiply this. If you use 5 to multiply 6, you have 30. You have to put down the 0, then you carry 3. If you use 5 to multiply 5, you have what? 25 plus 3. 3 is actually what? 28. 20 here, just bring it down here. Okay? So divide both sides by 100. You now have 100x all over what? 100 equals to 28,000 all over what? 100. This cancel this cancel this, this cancel this. Now I have x is equals to what? 280 what? Gram. So you realize that 500 gram will actually produce what? 280 gram of what? Of calcium oxide. Why, if you are to relate it with the amount of carbon oxide that 500 will produce, we have to relate it with 100 gram produces what? 44, which we calculated before, 44 gram. 500 gram will now produce what? X. So you can do that and drop the answer in the comment section. I'm dropping an assignment on the board. So this is the assignment. Calculate the mass of oxygen produced from the decomposition of 1,000 grams of potassium chlorate. Potassium chlorate is also called potassium triazoxide chlorate 5. All right. If you calculate the oxidation number of chlorine here, you realize that it's actually 5. All right. So what is the mass of oxygen produced from 1,000 grams of this? Calculate that. Send your answer to biologyaccess@gmail.com. Thank you for watching.